Saya Roshan Terry dari Dinamis dengan tip. Kebanyakan orang percaya bahawa cara paling baik untuk belajar ialah dengan mengikuti kelas atau mendengar ceramah. Namun, kajian menunjukkan bahawa cara terbaik mempelajari sesuatu ialah dengan melihat dan melakukan. Bukan hanya dengan mendengar saja. Pelatihan dalam kelas membentuk hanya 10% daripada pembelajaran dan pertumbuhan sebenar. Manakala 70% pembelajaran terdiri daripada pengalaman dan 20% adalah melalui pemerhatian dan mencontohi orang lain. Pembelajaran berdasarkan pengalaman lebih efektif dan dapat membantu sekiranya anda melibatkan diri secara kognitif, mengasah kemahiran baru atau membuat sesuatu yang berbeza yang membolehkan anda bertambah maju. Bukan rumit. Anda tidak perlu mengikuti kelas yang mahal untuk belajar. Setiap orang boleh belajar. Jadi, nasihat saya kepada anda, pergilah dan alami sesuatu yang baru. Pemimpin yang hebat mempelajari sesuatu apabila mereka sendiri mempelajari melalui pengalaman. Terima kasih kerana bersama saya dalam tip kepimpinan.
Perdana Menteri Tun Dr. Mahathir Mohamad hari ini meluangkan masa meninjau hari pertama persekolahan di Sekolah Kebangsaan Kedawang di Langkawi. Tun Mahathir yang diiringi isteri Tun Dr. Siti Hasmah Momadi disambut Guru Besar Sekolah Kebangsaan Kedawang Amiruddin Mat dan meluangkan masa kira-kira 30 minit bagi beramah-mesra dan bertemu murid tahun 1 sekolah binaan. Seramai 110 murid memasuki tahun 1 di sekolah itu. Beliau turut melawat Sekolah Menengah Kedawang. Bercakap kepada pelajar-pelajar, beliau kongsi satu rahsia bagi pelajar yang kurang berkebolehan.
Saya ini bukanlah seorang penuntut yang terbaik. Walaupun saya dapat pergi ke universiti untuk mengambil ijazah kedoktoran perubatan, tetapi dalam kumpulan 70 orang penuntut-penuntut di universiti pada ketika itu, mereka mempunyai kelulusan yang lebih tinggi daripada saya. Saya tak sampai pun setengah daripada kelulusan mereka. Oleh kerana saya sedar bahawa saya bukanlah penuntut yang terbaik dan saya bersaing dengan penuntut yang amat baik daripada Singapura dan juga daripada Malaysia, saya terpaksa berusaha lebih daripada penuntut-penuntut yang lain. Di sini saya nak bagi tahu rahsia kita yang kurang kebolehan. Rahsianya mudah saja. Kita kena rajin. Kita kena buat lebih daripada orang lain buat. Kita tahu bahawa kalau kita buat sesuatu berulang kali, kita akan jadi cekap. Kalau buat sekali je tak jadi. Kena buat berkali-kali. Oleh kerana saya ketinggalan, saya bukan penuntut yang terbaik. Saya perlu kejar penuntut-penuntut yang lain. Kalau penuntut yang lain baca buku sekali, 2 kali, saya baca 10 kali. Sebab apa 10 kali? Kerana kita kalau buat sesuatu berulang kali, maka dia akan lekat dalam otak kita, dalam pemikiran kita.
Okay, good morning. Okay, remember to key in your attendance. At the moment, only 19 responded. Okay, let's start with our lesson. So today, still chapter 1, exercise 8 to 16, page 6 to 12. And then you need to complete revision 1, chapter 6. Okay. And your project is chapter 4, page 1 to 1. Okay. Earlier on Tuesday, we have learned direct variation. Okay. Now is direct only involve uh, two two variables. Okay, this one involve uh, uh, three variables, one, two, three, and above. Okay, so we look here joint variation. Okay, still direct variation. Okay, because everything on top. So W varies directly x and y. When you change the varies to equal sign, you always put the constant k in front. Okay, so from here, it can be also y varies directly x power m, z power n. That means the m or n can be 1, 2, 3, 1 over 2, 1 over 3, and so on. That means it can be whole number or fraction. Okay, because the x and z is still on top, is still direct variation. Okay, then we look at example 8. Write the relation using the symbol varies and in equation form for each of the following. Okay, so A, P varies directly as Q and square root of R. It means P varies Q and multiply square root of R. When you change into equation form, it means equal, you put the constant K in front. B, y varies directly as the square of w and the cube of x. Okay, directly. So from here, y varies direct, that means on top, square of w square, and cube of x, means x cube. When you change the varies form equal sign, put k in front. Okay, C, the volume of prism B varies directly as the area of cross section A and its height h. Okay, volume, that means the length times width times height. Okay, but the formula for prism is area of cross sectional area, cross section times the height. Okay, this formula actually is given in SPM, but you must understand what is meaning of cross section. The area already, that means if let's say, okay, uh, this is the prism. Okay, this trapezium. So prism, that means involving more volume. Okay. What's the meaning of cross-section area? That means how you cut it, you will get the same area. That means I had to cut like this. Okay. That means from the chopping board, I cut into the shape of trapezium in this situation. Only you, whether cut in front or at the back, you still get the area of a trapezium. That's the area of cross-section. Okay. You cannot cut from bottom or at the side because the area will be different. So the area in this situation is area of trapezium, means the area of cross section times the height to get the volume. Means you get this area, the height is this one. At this situation, the height is here. Okay. To get this the area times the height to get the volume. Okay. Sometimes it will be like slipping type. Okay. Why is it called height? Okay, so this is the area of trapezium. Okay, then this is the height. Okay, so how you get the area of volume of prism. Okay, so from here, the volume varies directly A times H. So this varies change to equal, in this case put in front. So D, the mass W of a cylindrical metal rod varies directly as the length P and the square of the diameter of a base D. So you must understand the meaning of cylinder. Okay, this is a cylinder. The length P, this is the length P. Okay, it should be called height also because it is slipping. Okay, the condition of the thing is slipping. That's called is uh, the length. Okay, if it's not slipping, it means the height. The square of diameter. Okay, this is the diameter. So the mass, that means, is the volume of the cylinder. Volume of cylinder is pi r square h. Okay. So using what is given to you, W varies direct, W varies P and square of D, P times D square. Okay. W varies P times D square. When you change varies into equal, the K put in front. Okay. The formula actually is pi volume equal to pi r square h. Okay, that is the um, formula. So example 9, y varies directly as x and z. Okay, so y varies x and z. Okay, so show here first. Okay, y varies x and z. Direct is on top, both on top. Then change this one into equal sign, put k in front. Then given y equal to 12, x equal to 2, and z equal to 3. That means x2, y12, z3, put inside to find the value of k. Okay, y12, x2, z3. So to get the k is 2. Then k equal to 2, you replace inside here. Okay, you get y equal to 2xz. That is to express y in terms of x and z. That means when you express y, the x and z must be on the right, all on the right except for y. Y must be positive 1. Then find the value of y when x equal to 5 and z equal to 2. So x to 5 replace with 5 and z replace with 2. Then from here calculation, I get y equal to 20, final answer. Okay, example 10. Charles' law states that for a fixed mass of gas, the volume V center cube of the gas is directly proportional to its absolute temperature, T in Kelvin unit, if the pressure of the gas is fixed. It's given that a container contains 30 centimeter cube of gas at a temperature of 30 degrees Celsius. Okay, we say the formula for the conversion of temperature of degrees Celsius to Kelvin is equal to 203 plus x Kelvin. Okay, so A, express V in terms of T. Okay, so you must understand to find the volume. Okay, it says directly proportional, that means V varies. Okay, V varies, then T. Okay, V varies T. is given, okay. Then from here, the T must be in Celsius, okay. The T must be in Celsius. So we look at the answer. V varies T, okay. So given the volume center cube is 30, so V is 30, okay. And the T given uh, in Kelvin, that means 273 plus X, okay. So V varies T, so varies change to equal sign become KT, okay. So K constant, the T replaced with 273 plus X, 273 plus X. So V30 replace inside, okay, and the X is 30, so X degrees Celsius 30 replace inside. So from here, I can find the value of K, okay. So from here, add up, then 30 divide this one, okay, answer in fraction, okay. Better put your answer in fraction, always put in fraction, because then if you put in decimal when you round off, the final answer will be different later on. Okay, always in this kind of situation, any question involved, the best is always in fraction. Okay, then replace the k 10 over 101 inside the here to get so that you can express v in terms of t. Okay, after that we look at b, calculate the volume in centimeter cube of the gas if the temperature changes to negative 11 degrees Celsius. Okay, so we write down the expression again. Then the T, okay, T just now is 203 minus plus X. So because it's in Celsius, the X is in Celsius, so negative. We cannot put straight away T because it's not given the T value. So we have to replace this one. Okay, because the X given in Celsius is negative 11. So you replace it with negative 11. So 273 minus 11. So multiply this one, you get the final answer in centimeter cube. So example 11, Madam Sun saves her money in a savings account. It is given that the interest I received varies directly as the principal P and the period in year T of the savings. Okay, so from here I need to create the variation first. I varies directly, means okay, I know that I varies directly, P and T. Okay, all direct, is all on top. Okay, so from here PI varies directly, PT. Then from here equal, this one varies, I change to equal sign, the K put in front. Okay, then it says interest I is 200, so I replace I with 200. P is saved 4,000 for 2 years. That means the period, the time is 2 years, so P I put 2 years. And the principal is P, okay, want to save the principal 4,000 ringgit, so I put 4,000 in the P. Then from here I find the value of K. Then after the K, okay, from this situation, you can straight, if let's say you put in fraction also can, okay, if you put in fraction, you will get one over 40, okay. When you divide everything, you get exact 0.025, then you can put in decimal because it's that as you didn't round off. So we want to put in decimal, make sure don't need to round off. Okay, if not, you better put in fraction. So from here, we got the K value. replace inside the K, so you get you have to express the I equal to 0.025 PT. Then look here, count A. Calculate the period of savings for Madam Soon to receive an interest of 650. It means the I must replace with 650 with a principal of 5,200. So the principal P, I need to replace with 5,200. Only I can find the value of the period, the time, okay, the year, sorry. So period in year. So from here, I replace the I with 650 and the P I replace with 5,200. So I get the value of T. So T calculation, I get 5 years. Because T is in year. Then B, Madam Sue wants to get the same amount of interest but reduce the period of the savings in A. Does she need to increase or decrease her principal? Explain your answer. So we will look at this situation. Okay. This one that we learned in on Tuesday. Okay, we have understand that when P increase, the T will decrease. Okay. Okay, let's look at the previous lesson so that you understand more. Okay, for this situation, if this one, okay, directly this one, if this one double, this one also double. If this one reduce, this one also reduce. If reduce half, this one also reduce half. Okay, so we look at, let's understand the situation. Okay, if this one goes up, this one also goes up. Only you get the same constant. Okay, it cannot be this one goes up, this one comes down. Okay. Okay. Okay, we look properly. Y varies here. Okay. If this one up, that means this one must be up. If this one increase, this one also must increase. You see, if the Y increase, the T also increase. So you will get the constant value same. Okay. Okay. So same with this situation. If let's say I increase, the P also increase, or T also increase. If I decrease, the P also decrease, and T also decrease. Okay. If let's say, okay, in this situation, okay, but the P and T, if I increase, not necessarily the P and T both increase. Okay, it depends on the situation. Okay. So we look here. Madam Sue wants the same amount of interest, but reduce the period of her savings in A. Okay. So the time she want to reduce goes down, but this amount of interest is the same. Okay, doesn't change. Okay. If this doesn't change, this one period goes down, So what is the P? Is it increase or decrease? If the P is decrease, okay, this one goes down, then goes down, this one should be going down. It should be reduced, the interest, okay? So if you want to maintain the same, if this one goes down, this one also must go up. If the period goes up, that means the principal will go down, okay? That is the situation, how we look at the variation, the expression. So from here, okay, so if you want to, this one same amount, but reduce the period of time, that means she put from 2 years, maybe for 5 years, she decreased to 3 years. That means this one also, you need to put up increase, okay? So to maintain the value of I in the equation, when P decreases, the T increases. When P increases, the T increases. So the principal has to be increased to get the same amount of interest if the period of the savings is reduced. This is because the interest received is directly proportional to the product of the principal and the period. Okay, so we look at this situation. This is the proper way to write the answer. Okay, you want to explain your answer. Because the interest received is directly proportional, this interest is directly proportional, that means varies direct, okay, or varies directly. So, or directly proportional to, okay, that's why we use directly proportional, okay. So the interest proportional to the product of, means the multiply between the principal and the period. Okay, this is how you write down your answer. Okay, so the principal has to be increased to get the same amount of interest if the period is reduced. Okay, so we look at this one situation. When the number of doors open increases, the time taken for the pupils to leave the hall decreases. Okay. Similarly, that when the number of doors open decreases, the time taken for the pupils to leave the hall increases. Okay. The change in the number of doors open leads to an opposite implication of the time taken for the pupils to leave the hall. The relation is known as inverse variation. Okay, so we look at the situation here. Y varies inversely of X. So the X at the bottom. Okay, when inverse 1 over. Okay, so the X bottom. So if this Y, let's say the door is Y, the pupils is X. Okay, door increase, the pupil decrease. Okay, if your door decrease, the pupil increase. This is the same situation like just now. Okay, it's called dyx. Okay, so this one is the same, no changes. If this y goes up, this x must go down. If this y goes down, this x must go up. Only will balance. Okay, that's why the door increase, the pupil decrease. If the door open decrease, the pupil will increase. Okay, this is a situation to let you understand what is called inverse variation. So in inverse variation, variable y increases when the variable x decreases at the same rate. So we look at example 12. Chiaming takes part in 42 km marathon. The table shows the relation between the time taken by Chiaming and his average speed. State the change in average speed if the time taken increases by 2 times. This average speed. Okay, so this is the time taken. The time increase. Okay, the average speed increase. Okay, so from here, if the time increase by 2 times, that means you see 4 and 8. 4 times 2. This one decrease also 2 times. Okay, 10.50 divided by 2, you get 5.25. This is called inverse variation. Okay, so then times 2, this one divide 2. When time increase 2 times, then the average speed decreases 2 times. So inverse variation, y varies inversely x. Okay, it can be y varies inversely, look at inverse as x, y is inversely proportional to x, inverse. Okay, so if for this graph, you must draw y over here, 1 over x is over here. Okay, if you draw y and x, not 1 over x, if x, it will be like this. The graph will be like this. It means if this decrease, the x will increase. If x increase, y will decrease. Okay. If x decrease, the y will increase. You see, x decrease. Okay, less and less and less. But the y is greater. And y is less and less and less. The x is greater. Proportion. Later on. Then A, the value of xy is a constant. Okay, y say xy is a constant. When you put the x over here, become xy. When you change this one, become equal. Okay, so let's look at it. When this one, when you change to equal sign, it become like this. K is always on top. Okay, cannot be in front of x, must be on top. In this equation, always inverse, K must be on top. Okay, then this K is over here. X divide over become xy like this. So K equal to xy. Okay, so xy is a constant. Xy is a constant. B, the graph of y against x is a hyperbola. Okay, y against x is hyperbola x. And the graph against y against 1 over x is a straight line. Starts from the origin. Must always start on the origin. Start from elsewhere, it's not inverse variation anymore. C, y varies inversely as x. Okay. So relation between the value of k and the concept of proportion. Okay. So just like what you have learned in your direct, okay, it's the same situation. Okay, the x and y when you multiply, okay, you need to get the same value of constant. Okay, it means this one multiply. If the k is same, that means that is the correct equation. Okay. So the gradient is also, okay, this one is, look at y to 1 over x, inverse. So the gradient is y dy 1 over x. Okay. So remember the formula for gradient, y2 minus y1 over x2 minus x1. Okay, so from this situation, okay, let's say this 1 over x1. Okay, this one is y1. This one is 0, 0. So equal to y1 minus 0 over 1 over x1 minus 0. So you get final answer y1 over 1 over x1. This is how you get this one. So 1 over x1 is x1 on top. So x1 multiplied y1 equal to the constant. So do you want to find the constant? Okay, using the gradient also can. Okay, so you can form k over x equal to y, same as this one. So inverse variation, okay, this one is the, okay, just now that we learned, hyperbola straight line must start from the origin. This one we have learned just now. Okay. So A, okay. For this situation, this one is 1 over x power 2. Okay, it can be 1 over x power 3, it can be 1 over x power 4, it can be 1 over x power 1 over 2, and so on. This one just same like direct variation. Okay, so it can be written as, okay, because you still get from origin, okay, and you still an inverse variation. Because the x is still at the bottom, it's not on top. But it must be positive, cannot be negative. So from here, relation x can be power n. If equation, okay, form will be equal, k must put on top. So n can be 1, 2, 3, 4, 5, or 1 over 2, 1 over 3, 1 over 4, and so on. Okay. K is the gradient. So example 13, okay, that is the theory. Okay, it is given that the time needed t to assemble a piece of furniture varies inversely as the number of workers x. Okay, so t varies inversely as the number of x. Okay, so when you change equal sign, k must be on top. Okay. Then by calculating the values of x t, means when you put, you want to find the constant, okay, so x times t, and x squared t, determine whether t varies inversely as x or x squared. Okay, so you need to find the x squared, then you multiply with the t. You get the same value for all of it. X squared means 2 squared times 180. You get this one, 3 squared times 120. Okay, let's check whether it's same or x times t, straight away everything x times t. That one is the correct one, or x squared is the correct one. Okay, so from here, even the x is now 2, 3, 4, 5, 6, t 180 until 60. Okay, so x times t, I get 360, x times t, 360 or 360, x squared times t, means 2 squared times 180, 3 squared times 120, and so on. I get different value. So the final answer will be ST. Okay. Okay. So the value of xt is a constant, whereas the value of s squared t is not a constant. Okay, this is how we write it. Okay, t varies inversely as x, that t varies inversely as x. So we look at example 14. Two quantities x and y vary based on the table. By using a super scale, draw the graph of y against 1 over x and show that y varies inversely as x. Okay, so you need to find 1 over x first. Okay, to draw the graph y to 1 over x. So you get 1 over x, 1 divided by 2, 1 divided by 4, 1 divided by 5, 1 divided by 10. Then you plot the graph. You use your own scale. Refer to the table. Okay. So we let's say 1 over 2, you get 0 0.5. 1 over 4, you get 0 0.25. This one must put in decimal. If it's in fraction, you cannot find the points. 1 over 5, you get 0 0.2. 1 over 10, you get 0 0.1. So from here, y is 843.2, 1.6 given. So we can use maximum is 8, minimum is 1.6. I can use 2 lah. Okay, 2, 4, 6, 8. Okay, for this one, 0.1 minimum, maximum, the minimum is 0.5, maximum is 0.1. Okay, maximum 0.5, minimum 0.1. So from here, I can use 0.1, 0.2, 0.3. It's not logic to use 1, 2, 3, 4, and so on. So I write 0.1, 0.2, 0.3, 0.4, 0.5. Okay, so then I plot the graph 0.58. Okay, over here 0.254, 0.254. So here 0. This one you need graph paper. 0.23.2. 0.23.2 is 3.2. 0.1, 1.6. 0.1, this is 1. 1 is over here. Okay, 1.2, 1.4, 1.6. Okay. Then from here, I plot the graph. Is it a straight line? Yes, it's a straight line because it's y against 1 over x. Then it passes through the origin. So y varies inversely as x. If it didn't pass the origin, then it's not y varies inversely as x. So y varies inversely as x, 1 over x. If y varies inversely square of x, x squared, inversely cube of x, x cubed, inversely square root of x, square root of x, or x power 1 over 2, inversely as cube root of x is cube root of x or x power 1 over 3. Okay, example 15. M varies inversely a square root of L. So M varies inversely 1 over square root of L. Okay. So when you change it, M equal 1 over k over square root of L. Okay. So this one, M varies 1 over square root of L. M equal k square root of L. Then you look at the answer, there's no square root of L, but there's a L power 1 over 2, so that is the final answer. M equal k over L power 1 over 2. Then you look here, y varies 1 over x. Okay, y equal to k over x. Okay, k must be always on top, as I mentioned earlier. So example 16, given y varies 1 over square root of x. Okay, so we change varies equal k put on top. Okay, y equal k put on top. Then replace y with 6. Okay, and x with 4. So from here, I can get the value of k is 12. Then k 12 replace inside. Okay, y equal to 12 over square root of x. Express y in terms of x. This is the expression y in terms of x. Y only, the rest of on the right. Then find the value of y when x equal to 9. So x replaced with 9, so you get the value of y is 4. Okay. Just now somebody asked me a question. Okay, at the moment, the 5 responded for the attendance. Okay, 3 more not inside. Okay, another 10 minutes left, so I think you can quit Google Meet now. Thank you very much.